Relying on raw LLM prompting to build enterprise software eventually leads to a breaking point. Without a structural foundation, the code becomes a tangled web of dependencies that collapses under its own weight, unless it snaps into a rigid grid of architectural constraints. This failure stems from a lack of deterministic boundaries. When an AI generates code without these guards, the context window becomes saturated with noise, leading to architectural drift that compromises the entire system. To solve this, we separate the labor. Humans exclusively design the system blueprints, while specialized AI agents act strictly as the execution engine for those specific designs. This requires a shift in how engineering teams operate. The goal moves from using AI to write code to architecting a blueprint for the AI to execute. This is the foundation of the 10x Engineer Framework, a 10-stage automated pipeline where human-defined constraints guide every step of the AI's output. Measured technical leverage is no longer found in the speed of text generation. It is found in building execution loops that enforce these blueprints at every layer. The process begins with the system blueprint architect. Natural language requirements are immediately converted into UML diagrams, establishing the rules of the system before any code exists. If the agent attempts to generate a path that violates the blueprint's logic, the validation loop triggers a rejection, forcing it back into compliance. Once validated, the system extracts precise data, providing estimated token costs and latency projections based on the proposed architecture. Systems change, but the reasoning behind those changes must remain accessible. Component 2, the Automated ADR Manager, uses LangGraph to maintain a persistent state. During a refactor, it populates a record of alternatives considered and the reasoning for the final choice. A legacy auditor agent then monitors new commits, flagging any code that contradicts the decisions documented in the ADR history. By enforcing visual blueprints and tracking state, the system keeps the LLM's output within the specific bounds of the original human intent. As files accumulate, context limits become a bottleneck. We address this with the context pruner. This agent maps only the relevant functions for the task. It removes noise, creating a JSON context map to maximize LLM accuracy. A vibe check agent monitors the token-to-output ratio, alerting the engineer if context becomes polluted. Next, the focus shifts to data structure through the schema-first DB orchestrator. The agent enforces strict third normal form patterns, ensuring database normalization before any ORM code is generated. It tests this structure in a shadow database, using synthetic data to verify indexing and migrations work under load. Aggressive pruning and schema validation ensure the AI only operates on parameters that have been verified for efficiency. Component 5 is the contract-first API designer. Here, the open API spec is finalized before any backend or frontend code is authorized. This locked contract allows agents to work concurrently. The backend routes and frontend types are generated from the same source of truth, preventing integration drift. A breaking change detector compares the new spec against previous versions, highlighting exactly where the update will cause downstream failures. Security is addressed next through the Security by Design Reviewer. Integrating with SemGrep or Snipe, the agent performs AST analysis on the design. Identified logic pitfalls trigger a strict human review requirement. A pen test agent then injects malicious logic hacks, verifying the architecture resists common exploits. Moving security into the design phase shifts the process from reactive patching to foundational prevention. Component 7 is the Observability and Telemetry Architect, which ensures every critical path is instrumented from day one. It automatically injects OpenTelemetry spans into the code and generates the necessary Terraform files to build dashboards in Grafana or Datadog. A Chaos Monkey agent then simulates high latency scenarios, testing the retry logic to ensure the system recovers gracefully under pressure. This leads to Component 8, the Spaghetti Detector, which enforces code quality standards. This agent calculates the cyclomatic complexity of every PR. It rejects code if functions exceed 50 lines, providing a refactor roadmap to simplify logic. A dry agent scans the entire repository to find duplicated logic, suggesting centralized utility functions to keep the codebase clean. These automated audits and telemetry checks ensure the AI produces observable systems that are structured for long-term maintenance. To ground these agents in proprietary knowledge, we use the MCP Bridge Builder. By using the Model Context Protocol, agents gain access to real-time Jira tickets and internal documentation, allowing them to follow company-specific standards. Custom MCP servers can also provide read-only access to production databases, letting agents analyze real-world data distributions to inform their architectural choices. The final stage is handled by the README and onboarding agent. The agent generates a contributing.md that focuses on the why behind the design patterns and clarifies potential gotchas for future developers. It also creates setup scripts and architecture walkthroughs, ensuring the final structure is as understandable to humans as it is to the agents. This pipeline ensures the final output is more than raw code, an integrated system with the necessary documentation for human engineers to take over. These 10 components work together as a single circular pipeline. Within this framework, every stage is governed by strict constraints, from schema normalization to security audits, ensuring the AI never operates in a vacuum. Engineering in the age of Gen AI is not about the volume of code generated. It is about the integrity of the pipeline that produces it. Shifting focus from generation to execution allows teams to contain context pollution and manage technical debt at scale. To stay updated on these technical frameworks, tap the follow button, like and save this deep dive for your next project.